Okay, today we're going to be hopefully doing some stone pickups, adding stone pickups to supplement our stone drop-offs. So if we're in a move type move, we click a stack in our control, it's going to highlight a movement origin box, which you can then drop a stone. Oh, well, that is messed up. Uh-oh. Why does it not render? Huh. I'm a little confused why our mousestone 3 isn't rendering. Mousestone. Let's take a look at our mousestone render logic and see if we can figure out why that isn't rendering anymore. I assumed that was correct before we git commit our last change, but it's busted, so we'll need to fix it. I guess it just has to deal with the mousestone, right? Renders place stones, render stone, and mouse stone. So it might just... It should render each occupant of our mouse stones. So if we look at our occupants when we pick it up, we've got 3, so it's rendering 3. There, it's not rendering any. Now, it still has an occupant, so it should be rendering the stone 1 there. It tracks it. It's able to copy it from our mouse stones into our movement origin, but it's not rendering it for some reason. I don't know why that's the case. Okay. Shoot. I was ready to dive into a new feature, but I wasn't expecting to bug hunt. We've got the right number of occupants. I'm curious if instead of occupants we just do stone type. No. It's like we need a new... I'm going to turn off all that debugging. I'm going to add in a for loop to kind of render each occupant logic. So I'm just going to render the stone type of each occupant. Stone type is a member field, so we need to go to our members table at index I of our for loop and print up the stone type starting at 220. Actually, 220 will say debug y gets 220, debug y increment gets to, is it 30? Yeah. Well, no, yeah, 30. 30 so we can increment the Y by 30 pixels downwards, and then we'll do a little for loop here. I guess one of our mouse stone occupants do debug of our stone type. So this should print up our stone type. The first thing I want to do is place in a string of what our I is in our loop. So we're going to print an I, we're going to concatenate that with a colon and a space string, concatenate that with the actual stone type of the member, and then we're going to print it at the Y of our debug Y plus our debug Y offset or increment, and then we're going to increment our debug Y increment. By itself. So I'm hoping this should print up the stone types of the 3 occupants. Once we click on this, it does not. I don't know why it doesn't work. Our mouse stone occupants should be 3 once we pick up something. Oh, do you see it like almost render there and then disappear? How about... I'm confused why that's not even rendering debug info. There we go. But we need to increment the increment by the increment. It's like the stupidest thing I've ever said. It's like we need to this plus the increment. Oh, and you know what? Well, let's see. Still no. What the heck, man? Whatever. That's a little disheartening. So our mousestone occupants is correctly at 0, and then it's correctly at 3, and it renders 3 perfectly, but when we drop one stone, it drops both white stones for some reason. But it doesn't, I guess it doesn't drop both white stones, it just stops rendering the top standing stone. I'm curious if we add in another stone. Like, this is actually 4. Then let's add in, we'll make this a black F4, and Then we'll add in a white laystone in members 3. Okay. Now we should have 4 stones in the stack, and we'll see if there's any render issues there that might help us debug. We've got 4 stones. Oh, it's white's move, so it's black's move. We should be able to pick it up. Now, we've got 4 occupants. Does the same thing. It doesn't render the top. Oh god, and then... Oh god. That's jacked. Oh lordy. Okay, it's gotta be a mistake in our click detection, right? For our downward move type move logic for dropping stones. Bottom stone index. Bottom stone index is 1. What's weird is I mean, I don't know what's going on with that. So we should just drop the white stone. It drops the white stone and the top stone. The bottom stone and the top stone, it doesn't render anymore. But then when we drop this one, it drops both of them. So it's remembering them correctly, but the mouseStones logic is not being set appropriately. It's I feel like all the information inside our mouseStones object is correct in the sense that when we drop a stone, it copies that member into, see, it copies all of those values into the grid, into our movement origin grid. So that's not messing up. But what's messing up is the render for our mouseStones. Shoot. Are we printing at movement origin locked? No. That's so jacked. Oh, that's so jacked. Oh, fuck. I don't know what to do. I don't even know where to begin. It seems like our mouseStones... I guess I'll just hard code in some debug info. We're doing a loop. Let's see if we can do it right this time. I gets 1, comma, mouseStones dot occupants. Do. Now we're trying to print up. Actually, instead of the loop was messing up last time. Let's just do the hard coding like I said. We're trying to print up the stone type of our members 1. Set it to 220. Now we'll put in our stone type of our 2nd, our 3rd, and our 4th. This is our mouseStones stone type, what we're trying to print up here in the appropriate members, so we can see if we in fact still have them. 270, 330, 380. Okay, let's see. So look, we get all nil first, but when we pick them up and it's a black move, we have 1 is a lay stone, 2 is a lay stone, 3 is a lay stone, 4 is a standing stone. That's all correct. And then when we drop 1, that first one comes nil, but it stops rendering the 4th, even though our 4th is still a standing stone. So I was right that it was keeping that. It's just not rendering it for some reason. So what if in our debug rendering, or not our debug, what if we just explicitly say to render each occupant, actually each member, I mean, I'm going to say, hey, render 1, render 2, render 3, render 4. And then we'll see if that fixes our problem, and if so, then our for loop is getting jacked somewhere, but I'm not convinced that'll fix it. Oh, that fixes it. So something's wrong in the for loop right here. For whatever reason, Oh, wait. Oh, I think it's getting jacked up because, you know what we can do instead of, because the thing is the occupants changes depending how many things we render. So, for example, look right here, we're doing for every mousestone occupants, but anytime we press down, the mousestone occupants goes down. So that for loop will render less and less as we drop. So for right now, it's 4, so it's rendering 4 for the occupants. Then it's 3, so it's rendering 3, but the 3 it starts with is actually the first nil. Then the second laystone, third laystone, and then we drop to 2, so it'll only render the second stone, but we just dropped the second stone, so we don't render anything. So that's why that's happening, because occupants gets tinier the more we drop. So we have to actually just say, hey, just render every member in the mouse stone, and if it's nil, it's nil, but that should fix our problem. Nice. Okay, so that fixed our problem. Now we can get to what I was hoping to be the meat of the episode today. We can kill this. That's why well, I don't know exactly why we couldn't get our for loop render to work properly, but I want to actually revert all the tester stacks back to where we had it, because it was in white control, which made it easier. I'm gonna I just want to pull up the code here from our play state and get our this info back. So okay, so we should be back to where we started with that bug fixed at least. Nice. Okay, that's working. So let's get to, actually it's probably not a bad idea to just commit this fix. I'm gonna say corrected mouseStones occupant or mouseStones members render. Just to kind of snapshot that, and then we'll try to be able to pick up stones, the exact inverse of our dropping stones. So if we go to where we drop, so we've got the line for it here. Now we only want to be able to pick up a stone. What do we do here? Because we can only drop the amount of mouse stones we have occupants for. So if we have 4, we can only drop 4. But we can only pick up if our... God dang it. We can only pick up a stone if there is a stone in the grid, in the movement origin grid. That makes sense to me. So instead of mousestone occupants, we have to check to make sure that the grid at our movement origin row and our movement origin column, make sure its occupant's field is greater than 0, because that's the only way we can allow a pickup of a stone. Then, if that's the case, we can play the stone sound. And then we need to do the opposite of our drop. So in our drop, what we're doing is taking our mouseStones member at the bottom stone index, shoot. We need the top stone. So exactly like this. I said top stone index because if up is pressed, that means we have a stone in our movement origin grid. Now we need to take the top stone index of our movement origin grid and overwrite it, nullify it, copy it into our mouseStones. But we need to, so basically the grid, the space in which we clicked on, no. The movement origin row grid that would have to have an occupant in it, we're gonna take its top member. So in its members table, at the index of whatever our occupants are. So we put in the occupants. However many occupants, so there's one occupant, it takes in the first member needs to be nullified, right? Well, it needs to be copied before it's nullified, but it needs to be moved. If there's 3 occupants, then members at 3, yeah, that should be right. So there's the stone, there's the top stone of our movement origin column. Now we need to copy it into our mouse members. We need to copy 3 values. We need, first of all, the stone color, and it needs to be moved into the slot just beneath our mousestone occupants. Jesus. So however many occupants are in our mousestones, we need to add it. It's, oh God damn it. I don't know how to think this through. Let me look. Okay. So, oh, are you kidding? What the heck? Oh, give me a break, dude. What? What? I swear this wasn't just messing up. Why the top one? Why is only the top one messed up? Bro. What? What? Fucking what? What if we lose our third occupant? Does that mean the second one messes up? So confused. Yeah, Jesus, what? Why? I swear this was just fixed, wasn't it? We don't even do anything to our X or Y position here. Oh, God damn it. What changed, man? What changed? No idea. Why did that just break all of a sudden? We just had it fixed. What the heck, dude? We gotta be updating our members' X and Y position with our mouse position somewhere. I don't see where we're doing that. We've got to be doing that somewhere. Right here. Why is it always the top stone? The top stone doesn't get updated. What? What? How about just the same, where we say, for all 10 members, update that member with the mouse position. Stop playing those games, you know? Okay. 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 Okay, so the problem just comes from when we were doing for loops with a variable that was changing depending on the player input, so it was just kind of screwing stuff up. Anyways, we got that fixed. Let's go back to our drops. In our click detection here, if up is pressed, so just like how, what needs to happen here? We need to copy okay. We need to copy the stone attributes of our movement origin grid at the top stone location to be nullified. Well, it needs to first be copied into our mouseStone object, but at the index that is right below our first rendered stone. Now, right now, we don't have anything to kind of determine which is the first rendered stone, but we can we can cycle through all the variables. We can cycle through all the variables, and we can say for I is 1, for how do you exit a for loop if you're done with it? Maybe just return. So we're going to go through all the members of our mouseStone objects. Well, our mouseStone members objects. And if mouseStones members dot stone color, for example, does not equal nil, meaning it is populated, then we want to say I gets decremented by 1, and then, or I gets decremented by 1, and then we save that value into a field called pickup index or something. This is complicated because we're not actually removing the stones when we drop them. We're just nullifying their bottommost member first at the bottom stone index, and then we increment that, and then if we drop another one, we'll increment it there. So we have to also change our bottom stone index value once up is pressed, because bottom stone index will then become 1 less. I don't know. Stop. It's a tricky problem. I know there's a better way to do it. For now, why don't we just call this PU index gets saved. So if up is pressed and the occupants are greater than 0, that means we can have a stone to pick up. That's actually not the case, though. It's not the case, because if we have more than one, that's only the case if we picked up less than 5 objects. 5 or less objects. Wow, this is tough. Shoot, man. Let's just worry about it for now if it's 5 or less. So we're going to be saving that pickup index, then we're going to return. So we stop the for loop. I don't exactly know if that's how that works, but we'll see. So now that we've got an index, now this index will be the stone right before, it'll be the stone that would be picked up. It'd be all the stone type, all the stone attributes that would be picked up. Now, we're gonna copy from our grid its stone color. We're gonna copy it into that mouseStones.member at that PU index. PU index at that corresponding stone color. And the first thing we need to do is probably wipe. No, never mind. Yeah, we're gonna copy it into the PU index, into our mouseStones. So we also need to copy over our movement grids stone type and our movement grids stack order. Now, now we need to we are gonna increase upon dropping a stone, I don't think, oh no, we do increase right here. Okay, so yeah, we need to do this again. So we copy the values, we then increment our mousestone occupants, and we then decrement our movement origin occupants. And then we need to nullify all of the values that are in our... Shoot, man, this is hard as hell. We don't want this here. So we know it's occupied if we drop something in there, but we don't know if it's occupied if we pick one up. We'd have to do that separately, count the occupants, but we do need to nullify our values in our movement origin space, but not just that, we need to nullify it at the top index here, which is the occupants. And we need to do this before we decrement our occupants. So we're going to say dot members at its occupants index. And then we need to nullify the dot stone color. So we need this again. Just right here for stone type. We need to nullify that. And then we need to nullify the stack order. And then we need to decrement appropriately. Okay. Let's see. We can drop a stone. We can drop 2 stones. Can we pick up a stone? No. Nope. 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 It's probably this. Probably this. You know what? Instead of doing this, yeah, we don't have a, yeah. Okay, you know what? We actually, oh, well, what if we get, hold on. Instead of doing that, for our PU index, what if we do, we just say that PU index gets assigned however many mousestone occupants -1. Okay, then let's see that. Let's see if that allows us to pick up any stones. Nope, 380. So our grid, which is an occupant, at our member's index, and the index is an integer that is the number of occupants that is currently in our grid. Meaning the top stone. Now, let's just hard code this in at 2 for now. Hold on. We're actually... Nope. Fuck. Yeah, let me just try this at hard-coded index. So once we have two members in our movement origin grid, we can try to pick up a stone. There's two. Now let's pick up one. 380 fails. God damn it. I don't fucking know, man. Let's print up the pickup index. Okay. Actually, just right here. Now, the pickup index should be one less than the current occupants of our mousestone, which it is clearly not working. So, I'm gonna use the restroom real quick and I'll be right back and we'll see if we can figure this out. Okay. Where's our pickup index? Okay, we need to do this not upon a click detection, but just in general. Actually, no. Because then it'll just keep on going into negative. What we need to do... Oh, God. Yeah, how do we do this? Upon an up press, we're going to set PU index to our mousestone occupants -1. Let me just see if pressing up does it. No, it does not. get rid of pickup index completely. Well, we'll keep it because we need to. We just needed to get it working. So like, how about upon a move type move, not a mouse press, but on a move type move, we're setting it to be equal to here. If just on a move type move, we're going to say the pickup index gets mousestone occupants -1. Let's just see if we get the right variable. Okay, that's technically right. It gets -1 when there's no occupants, which is, I guess I'll say, if mousestones dot occupants is greater than 0, then we want to make it 1 less. So now we shouldn't get a negative pickup index. Okay. And then this should be 3, or yeah, 2, because there's 3 stones. And then 1. See, no, that's actually right. That's just, I mean, that's what I told it to do, but it's totally wrong. We're going about this pickup index all wrong. We don't want it to be the mouse occupants -1. We need to rehaul this completely, the pickup index at least. We need to do something like, instead of pickup index, no, I think we can keep, I mean, let's just keep pickup index till we figure out the right numbers, right? So upon picking up stones, we need to be able to, god dang. What do we have to do? If we have 3 stones, let's just walk through it here, like, okay, we've got 3 stones in hand. We drop 1, we have 2 stones in hand. Now, we need a way to keep track of the index of how many is in our top stone. So, I mean, no, we have a stack order. We have a stack. No, yeah, we have a, shoot. Let me just see. In our member class, stack order is like how high, what index is that stone. 1 is the first stone, 2 is the second. So it's like when we drop a stone, so here, picking up this stone would mean that we need to populate the first index. No, that isn't right. There's something I didn't think about when making this, and it's that, well, no, because the stack order of the standing stone there should be 3. Even though it's only on top of 1 stone, it should still be 3. Is that right? Let me print up the stack order of... Oh, lordy. Lordy, lordy, lordy. I've got an idea. In our member class, in our render, we are going to render the stack order in the top left of the self. So we're going to say love.graphics.print. We're going to be printing up the stack order in a string. So our self.stackOrder gets printed at our X and our Y location. Now we should be able to see the stack order on our members. Not exactly. And it's because we need the X offset and the Y offset. Let's say our X is now this. And our Y is now this. Oh my God. And then we need to render the opposite color. So if stone color is white, we need to set our color to black, which is this, so that we can actually read it. Otherwise we're God. Otherwise we're black, so we need to render a white color, which we do by values here. Now we also don't want to render it if it's nil, so self.stackOrder would have to not be equal to nil in order for this. And then we'll just be explicit here. Black and where stack order is not nil, then we render, so we don't get all those nils on screen. And then we render it at the X of our whatever our shrink is. So now we should be rendering stack order for each stone. Shit. Let's look at our indexes here. So the first argument is the string, that should be fine. Here's the x, which that's the appropriate amount of parentheses, and then the y, which also there's 1 parentheses, there's the 2, there's the 3, so actually, there we go. It just doesn't like that. What's wrong with that? Don't you like this, homie? Why, dude? Why is this like this? We still need the proper x values and y values, so here's the x. And here's the y. Okay. Now, let's see. Nope, not what I wanted. Okay. Stack order render. Okay, it's a little jacked, but I assume such. Okay. I guess it worked. See, so this, even though there's 1 stone in the hand, it still keeps the same stack order that when we picked it up. So if we want to pick up a stone, we need to do it based on the stack order of the first... Okay, I've got an idea. Well... So in this case, we need to, if we press up, we need to move a stone. We need to copy the stone from the movement origin into the mouseStones index 2. Now, why is it index 2 in this scenario? It's because the bottom stone in our hand is index 3, so we need to have 1 less index than the bottom-most stone in our hand. So I think we need another variable that is stones in hand that keeps track of not the occupants, which doesn't actually change when we drop, but the amount of stones in our hand for our mouse stones. So I'm gonna give us a note for that. Say that's weird. But yeah, I'm saying if we count how many stones are in hand for our mouse stones, if we count the stones appropriately, we copy the pickup stones into it -1 index. Because if we have 1 in hand, see, that's not right either. It's the stack order, -1 on the stack order. So that isn't right either, because the stone 3, well, no, stone 3, no, yeah, that is right, stack order index. So it's like the stone that's in your hand, we don't want to know how, we don't necessarily just need to know how many stones are in our hand, we need to know that's tough. Yeah, we need to know the stack order of the bottom index in our hand. So yeah, what is the stack order of the bottommost stone in our hand? And then place pickup into that index, that stack order -1 index. That's why it's so confusing. Because it doesn't matter how many occupants we have, it doesn't matter how many stones are in our hand. What matters is the stack order of our bottommost stone in our mouse stone. So if we pick up 5 stones, shit, man. It's so hard. Because if we pick up 5 stones, we can't just... I don't know. It's complicated because we can't just pick up stones willy-nilly. We have to only be able to pick up stones that were dropped, which is the hard part. So how do we ensure we can only pick up stones that were dropped? Yeah. My thinking is we just set a stones picked up variable or something, and then toggle that as we drop, decrement it as we drop stones, increment it as we pick up stones, and you can't drop more than you had in your hand, and you can't pick up more than... no, that's not even right. Because you need to... I don't know, man. That's very tough. Yeah, I'm not sure. We'll have to figure it out piece by piece. But yeah, we did not even kind of solve our problem today. But we are realizing how difficult of a problem it is, and we've got a game plan. So I'm not going to take a look at our git diff because we got to rehaul things. So at least we fixed our drop bug, our stone drop bug, but we have a lot of work to do on the pickup. But we've got a game plan. I'm going to say started to implement stone pickup logic. Still way lasted. Okay, yeah, that's very tough. It's very tough. Well, we'll make little progress. We'll have to identify these problems one by one and you know, isolate them as we fix them, because we want to make sure our final game isn't buggy. And there's a lot of instances, lots of different things you can do in this game. So we just want to make sure it works properly. Okay. We pushed, so I'll see you guys tomorrow, hopefully with some more progress. We'll try to isolate these problems and fix them, knock them out.